Very excellent, Garrett. Garrett says make a right angle, so we make a right angle. Suppose we have a triangle like this, an oblique triangle, a triangle that does not have a 90-degree angle. We'll assign that to be angle A, angle B, and angle C. That means that this is side A, this is side B, and this is side C. An oblique triangle, we like to say something intelligent about the angles and the sides. But the only thing that we know how to do is to talk about triangles that have a right angle. So I will drop down a height, and a height or an altitude contacts the opposite side at a 90-degree angle. Now, eventually I'm going to have to get rid of H because oblique triangles don't show H, do they? So we'll have to get rid of H, and I got a tricky way of doing that, and you guys are going to help me out, and thus begins the proof. I wish I had a trigonometric function that dealt with those three pieces. I wish I knew whether sine, cosine, or tangent dealt with those three pieces. Is there anybody out there who knows whether you use sine, cosine, or tangent to deal with those three? Sine of angle A is equal to H over B. Excellent. We've said something intelligent, but there is an H involved. We're going to say something intelligent about this group right here. Sine of B is also equal to H over A. And this is where mathematicians get excited because they look at the two things they've written down and they say they share something in common. What do they share in common? They share the H. In fact, you could multiply this side by B to get B sine of A is equal to H, and A sine of B is equal to H. Cool. I've set them both equal to H. If they're both equal to H, then they're equal to each other. And so we have B times the sine of A is equal to A times the sine of B. So my goal was to get rid of the H altogether. And have I succeeded in doing that? Yeah, and not only that, but I now have some type of formula that involves absolutely nothing to do with the height, and instead it involves these sides and these angles and their opposite sides. And so as I look at this piece again that I have here, it says B times the sine of A is the same as A times the sine of B. Now that's kind of tricky to write. Maybe if we just changed it a little bit more and divided both sides by AB. So instead of writing B sine of A and A sine of B, what I choose to do instead is I divide. And what happens when I divide? Things cancel, and you get this new formula. It says sine of A over A is equal to sine of B over B. Well, look at that. That kind of rolls off the tongue, doesn't it? Sine of A over A is equal to sine of B over B. What does it say? It says sine of an angle divided by its opposite side is equal to the sine of another angle divided by its opposite side. And it holds true that it would be case for C as well. And so, in this little argument right here, we have proved the law of sines. Not too bad of a proof, huh? Kind of actually fun. It makes sense. We had a goal, and we came up with this. Sine of A over A is equal to sine of B over B is equal to sine of C over C. Beautiful. The law of sines. The law of sines is very useful, but it requires this. You need to have an angle and its opposite side, or an angle and its opposite side, or an angle and its opposite side. That is what drives the law of sines. Okay, here we go. Hope your lunch was good. We've got angle B is 32, angle A is 85. So I got 32 degrees for B, and I've got 85 for A. We got side B is 20. So here's the question. Do you have an angle and its opposite side? Yes, you do. All right, that's number one. So law of sines may be in play because we have an angle on the opposite side. Now, if you look at the very last sheet that you have in your notes, you might want to tear it off and put it in front of you. Do you remember talking about all these sides and angle postulates when you're in geometry? Yeah. So we're going to help you guys understand how to make sense of these, okay? So we're going to tell you what these mean, and we're going to start to classify them in just a second here. If I look at this situation right here, I've got two angles, and I've got one side, agreed? So the question is this an angle-side triangle, or is it an angle-side-angle triangle? Which one is it? Angle. You are correct. It is not angle-side-angle because the side, or 20, is not between 32 and 85. Now, it does turn out that those end up being the same because if you have two angles, can you find the third angle? Yeah, so they do end up being the same. So if you look at your sheet, if you're given angle, side, you can solve the law of the triangle by using the law of sines, and there's one solution. If you're given angle, side, angle, there's one solution. You find it by simply using the law of sines. So these work out really, really, really well for us. Okay? So in geometry, a lot of people forget the difference between these two, but it's important to note that the side sits between the two angles for angle, side, angle. So let's try to solve it. I know that side B is 20. I go sine of what over what? 32 over 20 is equal to sine of 85 over, is it over A or C? It's over A because I'm looking at its opposite side. I cross multiply to solve. I get 20 sine of 85 is equal to A sine of 32. It's the only time I'm going to write it out like that. You're able to see that in order to solve for side A, I need to take 20 times the sine of 85, and I divide that by the sine of 32. I get 37.6. That would be side A, 37.6. It's not degrees because it's a side. How do I go about finding C? Can I figure out angle C? Yeah, super easy. 180 minus 40, or 85, excuse me, minus 32. And I get 63 degrees. So now I can set up the sine of 32 over 20 is equal to the sine of 63 over C. If you kind of follow the pattern that we had before, I'll do 20 times the sine of 63. I'll end up dividing by the sine of 32. 20 sine of 63 divided by the sine of 32. 33.6. You try this one on your own. Go. We'll look at this problem. Example 2. Draw my triangle. I've got A, B, and C. Angle A is 40 degrees, side A is 10, and side C is 7. So I've got 40 degrees, A is 10, C is 7. What makes this triangle different from the first one we did? Yeah, in this situation, I've got two sides. The other one had two angles. So is this a side-side angle or a side-angle side? Which one is it? from geometry, remember, if you get side-side angle, backwards, that spells donkey, and that's bad, right? Okay, so that causes a problem. Now, if we simply go to our flow chart decision trees can tell us what to do. We've got side-side angle. We follow it down, and it says you have to make a choice. Is the side opposite the angle shorter than the other given side, or is the side opposite the angle longer than the other given side? Side opposite the angle is longer than the other given side. If the side opposite the angle is longer than the other given side, you just have one solution using the law of sines. So, in all these situations today, if you're given side-side angle, it's going to fall down to that spot. So we're fortunate. Life is good for us right now. So let's go ahead and then solve this triangle. Sine of what? Over is equal to sine of c over 7. So I want to solve for c. So I'm going to multiply both sides by what? 7. 7 sine of 40 over 10 is equal to the sine of c. Seven sine of 40 divided by 10, and I get 0.44995. 0.44995 is equal to the sine of angle C. Now, y'all just took a test. You should know a lot about sine and cosine. If I graph y equals sine of x or y equals cosine of x, what's the biggest spot it gets to? 1. What's the lowest spot it gets to? -1. So that means sine and cosine have to stay between 1 and -1. Is 0.44995, is that between 1 and -1? It is. So what you can do is second sine inverse that 0.44995. Instead of typing in, you just press second answer. It takes that thing and it throws it right there. Press enter, I get 26.74. So we figured out the angle C is 26.74. I'm happy I came up with 26.74. Anybody know why? Because it's smaller than 40. Because C is smaller than A, right? So that shows me that at least I'm reasonable in my answer. It doesn't tell me if I'm right, but it tells me if I'm reasonable. So we're going to go ahead and do B then. So I subtract from 180. 180 minus 40 minus 26.74, and I get 113.26. Can I now find side B? Yep. You've got the sine of 40 over 10 equals the sine of 113.26 over B. So 10 sine of 113.26, close my parenthesis, and divide by the sine of 40, and I get 14.29. And that's the largest of the three sides, which I'm happy about because it has the largest angle at 113 degrees. Questions on that example? Okay, your assignment